Welcome to this lesson on minimum experiments of truth. This is a critical concept in science and innovation that can save you enormous amounts of time, money, and effort. Let's start by understanding the problem we're trying to solve. Imagine you have a brilliant idea for a new product or technology. What do most people do? Most people make the mistake of building the entire thing. They spend months or years developing a full product, only to discover it doesn't work or nobody wants it. This traditional approach is expensive, slow, and risky. You invest huge resources before knowing if your core assumptions are even correct. The minimum experiment of truth takes the opposite approach. Instead of building everything, you ask, what is the one critical assumption I need to test first? Every innovation has a riskiest assumption. This is the one thing that, if wrong, makes your entire idea fail. The minimum experiment tests exactly that assumption. For example, if you're building a subscription service, your riskiest assumption might be, will customers actually pay for this? You don't need to build the whole platform to test that. With the minimum experiment, you test within 72 hours, learn quickly, and either proceed with confidence or pivot before wasting resources. Why 72 hours? This time frame is critical for several reasons. First, it forces you to be extremely creative. You can't build a full product in 72 hours. So you have to find clever shortcuts and proxies. Second, it prevents analysis paralysis. Many innovators spend months planning when they could be learning from real experiments. Third, it maintains momentum. If experiments take months, you lose emotional energy and team morale. Let me share a famous real-world example. When Drew Houston founded Dropbox, he had a risky assumption. Will people want file syncing software? Building a full file syncing system would have taken years and millions of dollars. Instead, Drew ran a minimum experiment. He created a 3-minute video demonstrating how Dropbox would work. He posted it online and added a sign-up form. Within one night, he got 75,000 sign-ups. This experiment validated massive demand without writing a single line of production code. The video took maybe 8 hours to make, not years. Now let's get into the scientific principles behind minimum experiments. This isn't just business strategy, it's rooted in the scientific method. Every minimum experiment is a hypothesis test. You have a null hypothesis and an alternative hypothesis. The null hypothesis is that your critical assumption is false. Your product won't work, customers won't pay, the technology is impossible. The alternative hypothesis is that your assumption is true. Your experiment is designed to gather evidence to reject the null hypothesis. Like any scientific experiment, you need sufficient evidence. What constitutes proof? Let's talk about the numbers. How many data points do you need from your minimum experiment? This depends on your confidence requirements. The sample size formula is n equals z squared times p times 1 minus p, all divided by e squared, where z is your confidence level, p is the expected proportion, and e is your margin of error. For 95% confidence with a 5% margin of error, assuming p is 0.5, you need about 385 samples. Let's calculate it. 1.96 squared times 0.5 times 0.5 divided by 0.05 squared equals 384.16. So about 385 people. However, for a minimum experiment, you don't need perfect statistics. Getting 50 to 100 responses is often enough to see if you're completely wrong or potentially right. Here's an important question. Why not just ask people if they want your product? Why do an experiment at all? The answer is that people are terrible predictors of their own behavior. They'll say they want something, then never buy it. Asking is cheap but unreliable. Testing with real behavior, like pre-orders, is far more predictive even in small numbers. Let me give you several types of minimum experiments you can run, depending on what you're testing. Type 1 is the landing page test. Create a simple web page describing your product with a sign-up or pre-order button. Drive traffic and measure conversion. Type 2 is the Wizard of Oz test. Make it appear automated, but do everything manually behind the scenes. This tests if people want the outcome without building the automation. Type 3 is the concierge test. Similar to Wizard of Oz, but customers know you're doing it manually. This tests if the value proposition works at all. Type 4 is paper prototypes. For hardware or physical products, make it out of cardboard or basic materials first. Type 5 is a single feature, minimum viable product. Build only the core feature, nothing else, to test the fundamental value. Let me give you an analogy from medicine. Pharmaceutical companies don't just give new drugs to millions of people immediately. They use phased trials. Phase 1 tests safety on 20 to 80 people. Phase 2 tests efficacy on 100 to 300. Only after success do they run massive Phase 3 trials. Your innovation should follow the same logic. Start tiny, test the critical assumption, then scale if validated. Another analogy comes from physics experiments. When testing a new theory, scientists don't immediately build a billion-dollar particle accelerator. They run small tabletop experiments first. Can we see any signal at all? If yes, then scale up. If no, revise the theory. Gravity wave detection started with small interferometers. Only after seeing promising signals did they build LIGO, the massive detector. Let's look at the mathematics of why minimum experiments make economic sense. Expected value equals probability of success times the value you capture, minus your costs. With the traditional approach of building everything, your cost C is enormous, maybe hundreds of thousands of dollars, but your probability of success is unknown. Expected value for traditional equals unknown probability times V minus $500,000. With a minimum experiment, your cost is tiny, maybe $500, and you learn the probability. Expected value for minimum experiment equals probability times V minus $500. After the minimum experiment, you know P. If P is high, you invest. If P is low, you pivot. You make decisions based on data, not hope. There's actually a formal framework for this called the expected value of information. Expected value of information equals expected value with information minus expected value without information. A good minimum experiment has high expected value of information relative to its cost. You spend $500 to potentially save $500,000 of wasted effort. If your experiment prevents a $400,000 mistake and costs $500, your ratio is 800. That's an incredible return on investment. Let me point out some common mistakes people make when trying to run minimum experiments. Mistake 1 is testing the wrong assumption. You need to test the riskiest assumption, not the easiest one to test. Ask yourself, if this assumption is wrong, does my entire business model or invention fail? If not, it's not the critical assumption. Mistake 2 is making the experiment too complex. Remember, you're trying to learn one thing quickly, not build a polished product. Mistake 3 is not defining success criteria beforehand. Before running the experiment, decide, what result would make me proceed? What result would make me stop? For example, if conversion rate is greater than 5%, proceed. If less than 2%, pivot. Define these thresholds in advance. Mistake 4 is ignoring statistical power. If your sample size is too small, you can't distinguish signal from noise. Let me share another famous example. Zappos, the online shoe retailer, started with a brilliant minimum experiment. The founder, Nick Swinburne, had a risky assumption. People will buy shoes online without trying them on first. Instead of building inventory, he went to local shoe stores, took photos of their shoes, and posted them online. When someone ordered, he'd buy from the store and ship it. No inventory, no warehouse, minimal risk. This is a perfect Wizard of Oz test. It validated the model before scaling. Once they saw people actually buying, they invested in building inventory systems and warehouses. But they learned first. Minimum experiments are not one-time events. They're part of a continuous learning loop. You form a hypothesis, run an experiment, learn from results, and iterate with a new hypothesis. This loop should repeat every few days, not months. Each cycle should take 72 hours or less. This rapid iteration is how you discover what actually works. Let's look at how this principle applies across different fields of innovation. In software, you use feature flags to test new features with small user groups and A/B tests to compare variations. In hardware, you use 3D printed prototypes and mock-ups before investing in tooling and manufacturing. In science, you run computational models and simulations before expensive lab experiments or field studies. In medicine, you test in vitro in test tubes before in vivo in living organisms. There's an important trade-off triangle to understand in experimentation. You can typically only optimize two of these three. Minimum experiments prioritize speed and low cost, accepting smaller scale initially. Traditional approaches prioritize scale from the start, which forces you to sacrifice speed and accept high costs. Let's talk about an important distinction: statistical significance versus practical significance. A p-value less than 0.05 means statistically significant. Your result is unlikely due to chance alone. However, statistical significance doesn't automatically mean business or practical significance. For example, you might prove that 2% conversion is statistically different from 2.1% conversion with enough samples. But in practice, a 0.1% difference probably doesn't matter for your business decision. You need practical significance too. For minimum experiments, look for at least 20 to 50% improvements to consider something practically meaningful. After running your minimum experiments, you face the crucial pivot or persevere decision. If you get a strong positive signal that exceeds your success threshold, persevere. Invest more resources and scale up. If you get a weak or negative signal, pivot. Change your approach, test a different assumption, or abandon the idea. You can set a pivot threshold mathematically. It equals your baseline expectation plus z times the standard deviation, where z is your confidence factor. The hardest part is avoiding sunk cost fallacy. Just because you've invested time doesn't mean you should continue if data says stop. Let me give you a practical framework for designing your minimum experiment. Step 1. Write down all your assumptions. Circle the one that, if wrong, kills your entire idea. That's your riskiest assumption. Step 2. Design the absolute cheapest, fastest test that could provide evidence about that assumption. Step 3. Before running the test, write down specific metrics and thresholds. What numbers would make you proceed versus pivot? Step 4. Execute within 72 hours. Use shortcuts, manual processes, anything to get real data quickly. Step 5. Analyze results with brutal intellectual honesty. Don't cherry-pick data or move goalposts to justify your desired outcome. Step 6. Make a clear decision. Pivot, persevere, or run another experiment. No wishy-washy maybe answers. Let's talk about real numbers from successful companies that use minimum experiments. Amazon runs thousands of small experiments every year. Most fail, but the few that succeed drive massive value. Typical success rate for experiments is only 10 to 20%. This means 80 to 90% of experiments show your hypothesis was wrong. But this is exactly what you want. You learn fast what doesn't work, avoiding huge, expensive failures. Here's a common question. What if my critical assumption genuinely can't be tested cheaply? What if I'm building a nuclear reactor or a space telescope? The answer is you can always test something that's correlated with your assumption. Break your big risky assumption into smaller sub-assumptions. Test those first. For example, if you want to build a Mars colony, you can't test that in 72 hours. But you can test habitat designs on Earth, in deserts, or underwater. Use proxy metrics and computational simulations. They're not perfect, but they're vastly better than building blind. Here's the amazing part. Minimum experiments create a compound learning effect. Your learning grows exponentially. L of t equals L0 times 1 plus r to the power of t divided by tau, where r is your learning rate per experiment and tau is time per experiment. If each experiment takes 72 hours, you can run 5 experiments per month or 60 per year. Compare that to traditional approach, where each build takes 6 months. You only get 2 experiments per year. That's 30 times more learning in the same time period. This is why minimum experiments are so powerful. Before we conclude, let's talk about ethical considerations in experimentation. Always be transparent with participants. If you're testing on real customers, they should know it's a test or early version. Never harm users just to learn faster. Your minimum experiment should not create negative experiences. Respect privacy and get proper consent. Just because something is technically feasible to test doesn't mean it's ethical. Let me summarize everything we've covered about minimum experiments of truth. First, always test your riskiest assumption first, not every assumption at once. Second, Use the 72-hour rule to force yourself to be fast and creative. Third, measure actual behavior with real stakes, not what people say they'll do. Fourth, always define success criteria before you run the experiment, not after. Fifth, accept that most experiments fail. That's exactly the point. You learn what doesn't work quickly and cheaply. Sixth, scale only after you've validated your assumptions, never before. Seventh, follow the scientific method rigorously. Hypothesis, test, analyze, iterate. Here's a final thought. In a world where most innovations fail, the ability to fail fast and cheap is your greatest competitive advantage. Minimum experiments transform failure from a catastrophic event into a learning opportunity. The goal is not to avoid all failure. That's impossible. The goal is to make failure informative and inexpensive. Learn fast, fail cheap, iterate quickly. This is the path to breakthrough innovation. Now go design your minimum experiment and test it within 72 hours.